Hello everyone, my name is Paulina, welcome back. Today we will continue discussing the concept of time value of money, and we'll look at some more involved specific examples. Just a quick note before we begin: if you are brand new to time value of money, you have never heard of the concept, you have never heard of present value, future value, compounding, discounting, please refer to my previous video and watch that first. So let's begin. Let's draw our timeline again. We will need it. And let's make it a little bit bigger because it's going to be more writing. 1, 2, 3, 4. And we will have 5 years examples again. I always recommend everybody, and I even do it myself, draw the timeline before you begin tackling time value of money problem. Because here we only have 5 examples. You might think 5 years example, you might think, oh, it's really easy, I'm not going to get confused how many years we're compounding. However, when you have a problem, when you have, let's say, 27 years until the event, 27 years of compounding, and maybe that period might split between 3 different periods, then it becomes more complicated and you might get lost and miss a year or 2 in the beginning or at the end, and that will give you wrong answer. So let's go back to the example that we finished our previous video with. We were trying to figure out how much money we need to put up in the bank in order to have $10,000 at the end of year 5, because we wanted to buy a motorcycle that cost $10,000. So in the previous video we determined that we do need $6,209 to put it in year 0. However, we don't have $6,000 right now. What we might be able to do is to put certain amount of money every year. So we'll put some money today, year 1, year 2, year 3, 4, and so on. And our rate is again 10%, as in the previous video. What we need to figure out is how much money do we need to put every year in order to have $10,000 at the end of the year 5. Take a guess. If you guessed $2,000, that is not correct. If we do divide 10,000 by 5, we do come up with $2,000. But don't forget that we also earn the rate of return of 10% of each of our payments that we make to our savings account. So how do we solve for this problem? Let's go. In order to do that, we need to think back to our future value formula, because this is our future value. So what is our future value? It is known. This time it's $10,000, and it is sum of all the payments we make compounded at the corresponding rate, which is 10%. And raised to the power of the number of periods remaining. So if we put up some sort of X amount of money at the year 0, how many times we're going to compound it? Let's see. 1, 2, 3, 4, 5. So we will multiply it by 1 plus the rate, so it gives us 1.5 to the power of 5. We put the same X amount of money at the year 1, and we will compound it 4 times. The same with the remaining periods. So 1.1 to second plus x times 1.1 to the first. And first we obviously can omit because I made a mess. In this example, we're making exactly the same dollar contributions to our savings account. It doesn't have to be the same. It will make problem more complicated, but I'm sure a more realistic example would be that it is a different actually dollar contributions. Here, however, it's a very easy equation with one unknown that just by rearranging, if you have trouble rearranging and solving this equation, you need to go back to your basic, probably middle school algebra, and review that. I will not gonna spend any time doing it here. I will just give you the answer, and it is $1,638 we need to put up every year into our bank account that earns us 10% a year rate in order to have saved $10,000 at the end of the year 5. So let's look at the different example. Let's say we have $2,500 that we can put in our bank account today. We don't think we have some unexpected expenses we have to pay, tuition for college next year, so we're not going to be able to put up anything there. But after that, we think that we're going to find a new job and we'll be able to contribute again. So we will put some X amount of money in accounted year 2, 3, and 4. And we need to determine what this amount of money will be in order for us to be able to buy a motorcycle at the end of the year 5. So again, going back to our future value formula, we write down, so 2,500 will be compounded 5 times, 2,500, 1.1 to the power of 5, plus 0 will be compounded 4 times. It doesn't matter because 0 times any number equals 0, so we can skip it. So we go back straight to the year 2 at 10% rate, compounded how many times? Let's say 1, 2, 3. Then we contribute again, and we have 2 years remaining, and then we contribute again, and it's only 1 year remaining. Again, very simple equation with one unknown. We solve for x, and it is $1,805. Feel free to solve those equations by hand or by calculator or by Excel and double check me. Let's look at the different example. And in this example, you win lottery. You win $250,000, $250,000 lottery. And lottery company comes back to you, which they actually do in real life, and tell you, we can either give you $150,000 today, or we can give you $40,337 every year. What we want to try to figure out is this a fair deal? So with $150,000, it's very easy. We know that our amount that we won and we would like to have, because here they send 40,000 for the 5 years, so we do have a 5-year horizon again. So we want $250,000. So at the end of year 5, we'd like to have $250,000. We would go to our present value formula, and we will say 250,000 discounted at the 10% rate for 5 years. How much is it? 250,000 discounted at 1.1 for 5 years. Remember, this is our discount factor, is equal $155,230. They actually give us less money than we would have expected at the 10% rate. Very interesting. Why could it be? Remember in the last video I told you that 10% rate was pretty arbitrary. I just kind of picked the even number, and this is what we were using. So in this example, again, we use 10%. What if the lottery company thinks that the fair rate to use to discount $250,000 that we won is different than 10%? So we can find out what rate the lottery company thinks is fair in this example. So we know that the present value that they put on it is $150,000. We know that the future value is $250,000. What we're trying to solve is this interest rate x down here. This equation has only one unknown, but it's a fifth power equation. It would be a little bit tricky to solve on a paper. You do need to use either financial calculator, Excel, or some other software in order to solve this equation. I have answer for you already, or you can just solve this equation by substituting x for, let's say, 10, then try 9, then try 11, and solve it that way, whichever way you think is most easy for you. So when we solve for x, we get 11%. So if we apply the rate of 11% to our $250,000 over here that we want and discounted 5 periods, then this is what the lottery company actually gives us here. Similarly, they offer us $40,337 a year. If we were to apply the rate of 10% and try to solve for payment, let's see what we would come up with $40,949 payment here. Let's put it 10%. Our payment equals $40,949. We would think that again they offering us too little money, but then when we apply 11%, then we find out that this is actually a fair amount that they're offering us to pay. In the example of the lottery company, we won the lottery, we have to take what they give us. There are some situations where you can negotiate the discount rate that is more favorable to you, or and the other party will be negotiating discount rate that is more favorable to them. In this example, you would like the discount rate to be 10% or even less, because that way you will end up with a higher amount up front. However, in our example, we don't really have any power of negotiation. This is all that I have for you today. I hope you found it useful. Again, there are definitely much more, you can go into much more complicated examples. We do not have time to cover everything in this video. If you have any specific questions, please post it in the comments under the video or send me a personal message. If you would like me to cover a certain topic that is related to time value of money, or something else that you are interested in from the world of finance and investing, feel free and I will try to answer all your questions. Hope you found it useful, and I will see you later. Thank you. Bye.